Okay, last lesson in stats. I think the last lesson that we're actually going to cover in this course. So that's pretty cool. Well done, guys. You made it to the end. All right, let's take a look at confidence intervals. Not really very much math kind of needed. Maybe a little bit of subtraction, but really it's just kind of these three kind of ideas here that I want us to talk about. We've been using mu and x bar kind of interchangeably, but there's a whole bunch of math that goes into selecting samples from populations, right? There are two actually very different measures. We think of when we survey the whole population, that's kind of like doing a census. Everything gets surveyed, everything gets kind of questioned. We try to gather as much data as possible on every single object in the set. So, but that doesn't always work. Like, you know, for example, in your notes it says if a light bulb company wants to test the number of hours that a light bulb will burn before failing, it can't test every bulb, otherwise it won't have anything to sell, right? Quality control, you know, if you say your job is to test chocolate bars, make sure that they taste just right coming out of the factory. You can't taste all of them, otherwise there will be nothing left to sell. So you pick a sample, and there's a lot of math that goes behind choosing a good sample and having you know, really good representative data. And not anything we need to worry about, but again, definitely things that you will consider. Whenever we choose, whenever we are using a sample to represent an entire population, we have to consider a couple of pieces of information that goes along with it. And you might have seen this, you know, especially around election time when they do polling, and they talk about who's going to, you know, who's going to become the next prime minister, who's going to be the next president. There's, you know, there's kind of this fine print at the bottom of the screen when it says, you know, 43% of the people are going to vote for candidate A, and then at the bottom it says, you know, plus or minus, you know, 5 with a 95% confidence level or something like that. So these three words here kind of speak to that fine print that might pop up. First is margin of error. Margin of error is the possible difference between the estimate of the value you're trying to determine from a random sample and the true value. So margin of error looks like a plus or minus. Okay, so we might say that candidate A has a 43% chance of winning the election, plus or minus 5%. So that means that, right, a sample can't be perfect. So we think it's going to be, we think the answer is 43, but it could be as high as 48 or as low as 38. Okay, so that's kind of somewhere in there is actually the answer. But we have to also think about how confident we are in that range. So that would be our confidence interval. Okay, so well, actually, I guess I kind of lumped confidence interval in with margin of error. So the margin of error is just the plus or minus, and then the confidence interval would be the range that comes out of the margin of error. Okay, so we would say, you know, our confidence interval is 30 plus or minus 2. Plus or minus 2 is our margin of error, but this 28 to 32 is our confidence interval. Okay, and then the last kind of thing we need to think about is our confidence level. Now this is actually how confident we are that this range represents the true number, right? What the whole population would actually say. And usually our confidence intervals are 95%. It can be 90%. 99% is amazing. That would mean you had probably had a really, really big sample to look at. It's kind of rare, but usually we want to kind of hit for 95%. So we want to be able to say we're 95% confident that our data falls in this range, right? Because, you know, data can be a little bit tricky. The real world can be a little bit tricky. So these things kind of speak to that. So a confidence interval is used to make predictions about a population based on samples. And confidence interval is affected by the margin of error and sample size. So if the sample size stays the same, the margin of error increases as our confidence level increases. If the confidence level stays the same, then the margin of error decreases as our sample size increases. And that just means that the bigger your sample is, the more representative it is, and that means we can be more confident and have a lower margin of error, right? So these things kind of play onto each other. So if we're going to use a small sample, we might be less confident in that data. Okay, we might have a larger margin of error as well. And that makes sense if you're only going to poll a couple of people about how they're going to vote. A very small group of people don't kind of speak for a whole population, so you would have a very large margin of error if you were going to report on a small sample. All right, so let's take a look at what these questions might look like. I'm not even going to write them out for you again because you have it all here. Just kind of want to make sense of it. So a telephone survey of 500 randomly selected people was conducted in an urban area. The survey determined that 35% of Canadians from 24 to 45 years old have an e-book reader, and the results are accurate within plus or minus 5% points 19 times out of 20. Okay, the number of people in this age range in 2011 was about 8.7 million people, and we're assuming that the ages are normally distributed. So what range of people own an e-book reader? Well, 35% of Canadians have an e-book reader in this range, plus or minus 5%. Okay, so that's our margin of error, it's plus or minus 5%. And so that means that we have 30 to 40% of the people who own an e-reader, right? So that's from plus 5% and minus 5% on our 35%. So that's our confidence interval, right? So plus or minus 5% is our margin of error. 30 to 40% is our confidence interval. Determine the certainty of the results. The certainty is asking about our confidence level. Our confidence level in this case is given as 19 times out of 20, which is just another way of saying 95%. Okay, so sometimes we see this 19 times out of 20, and sometimes we see it as a percent. Okay, so that's our confidence level. It tells us how certain we are that this is representative of all Canadians. Okay, which is pretty good. 500 people were randomly selected, and we've got a 95% confidence level in that, so that's pretty good. How many people in Canada in this age range would you expect to own an e-book reader? Well, we know it's between 30 and 40%. So when we take 30% of 8.7 million, we get 2.6 million-ish. 40% of 8.7 million is, about 3.5 million. So there's somewhere between 2.61 and 3.48 million Canadians. Okay. Those are very specific questions, but normally what I'd want you to be able to do is I'd want you to be able to make a statement kind of like this. In this example, we can use margin of error and confidence interval to say a statement like, we are 95% confident that the number of 24 to 45-year-olds in Canada with an e-reader is between 30 and 40%. That's what this means. Okay, which sounds like you're kind of, I don't know, sounds like a little bit of a scam kind of thing, but it's just being true about the data. So whenever if you hear a poll about something that sounds a little bit fishy, you can kind of dig a little bit deeper and say, well, what's the confidence level on that? And what's the margin of error on that? And how certain are you in your results? So we can be a little bit more skeptical of the stats that we see. Okay. The second example is, saying, there was a poll conducted to ask voters the following question: if the election were held today, who would you vote for? Okay, the results show that 53% would vote for Smith, 47% would vote for Jones. Now, it looks like Smith is going to win, and except when we dig a little bit deeper, we see that the results are being stated as accurate within 3.8% points. So that means like plus or minus 3.8. 19 times out of 20, and that's that 95% confidence level. Okay, so if we look at Smith's confidence interval at 53%, but we do this plus or minus 3.8%, that means his range is anywhere from 49.2 to 56.8. Jones, who looks like they're trailing at 47%, has a range of 43.2 to 50.8. So it's likely that Smith is going to win, but we can see that the high end of his confidence interval is higher than the low end of Smith's confidence interval. So it's well within these stats for Jones to win. So if Jones wins, it's okay. Our data is actually still pretty good because we're only 95% confident in the data anyway, but it actually holds an opportunity for Jones to beat Smith. Okay, so that's kind of what happened. That's what happened in the last presidential election in the U.S., right? Hillary Clinton was polling higher than Donald Trump, but within that margin of error, actually, it showed that there was room for him to win, which of course he did because he is the president now. So when we look at polling numbers, we want to look more carefully at what's going on behind those polling numbers. Okay, so try the questions that follow and let me know if you have any problems.